Hey, hello everyone. My name is Mr. Omo Godwin, and today in Quantitative Reasoning, we'll be looking at a very interesting topic uses of bars, arrows, and shape. Uses of bars, arrows, and shape. So let's get to it, people. So we're going to look at first and foremost what we're talking about today in quantitative reasoning. Bars, arrows, arrows. We have bars and various kind of shapes in our quantitative reasoning. We're going to make sure that we use some of these shapes and how they represent what they mean. So bars and arrows and shapes are used extensively to create points, and sometimes it creates direct operation in quantitative reasoning. So the direction of an arrow could tell you what something is saying. Okay, for example, we could say 3 and a 2. This means a 5. So when you see the arrow going this way, it means, oh, there's an addition. Perhaps then we see something this way, and 3 and 2, and we have something like a 1. You already know this is subtraction. So that's what we mean when we look at different shapes and how we can use them to direct operation in quantitative. Although there are many clues and samples to discuss on the appropriate aidings, but for today, we're going to limit it to just bars or lines. So we are in quantitative reasoning. I always tell you guys, remember this guy here, sorry, taking it back, you have to come with your thinking cap. Okay, so in line with that, we are to work along quantitative and arithmetic line to understand the simple and use it to solve problems. We should understand samples and quantitative. What do you mean by arithmetic line? All your operator plus, minus, times, and sometimes divide. Yes. So we put on these things so we can make sure that they work for us. Now let's get into some samples like we have today. We have 3 and 2. So someone has already seen that this direction is telling me I have to relate with these two numbers to give me this answer. Yes. So somebody can look up and say, oh, Mr. Omar, I think I've already got it because it's going to be 3n times 2. That should give me 6. Now, if you've gotten this far, you should think, how do we get only 3? So to get your 3, it means what? You're going to divide. That means 6 over 2. Here 1, here 3. If you're going to get your 2, you divide 6 over 3. Here 1, here 2. Brilliant, isn't it? So that's how we do it. Now, in this case, you just have to study samples. 4 times 4, that gives me what? 16, because I observe that these two numbers should have something to do with this guy here somehow. And if I'm going to get any of this number, it has to be 16 over 4. Here 1, here 4. So we have them that way. Now let's see. Now I have another one. Beautiful. In this line of thought, one would be saying, oh, why didn't you just multiply? Remember, every sample have their own operation. So in this guy here, this one we have 3, 2, and a 5. Can someone tell me what the relationship is between these numbers? It's a plus. Good. So we say 3 and plus 2. That gives me a 5. Brilliant. Brilliant. So what will I do if I'm going to get my 2 and I have only 3 and 5? Because sometimes you do it that way. Let me just take one number off and try to see if you're smart. And that means my 5 minus 3, it's going to give me a 2. Also, if I'm to get this number, because since the addition of this number has given me just this, it means if I subtract 1, I'll get the other number. So 5 minus 2 here should give me 3. So that's how we got this guy and that guy. Thank you. So we'll move on to the next one. You already know what this is. It is 4 plus 4 here, and that is 8 here. So what we do is, if you're going to get the other 4, what do you do, boys and girls? We subtract 4 from 8, and that should give us 4. All right, so any of this number will fit in for that. What do you think we did here, boys and girls? Multiplication. Awesome. That's good, because we have 4 times 2 equals 8. You want to know a little trick? When you have multiplication, to get the other number, it's going to be division. Because I'm putting on my thinking cap. So each time you have multiplication giving you a value, to get the other numbers that gave you the value, the multiples of the number is just to divide. See now, watch it. 8 over 4 is going to give me 2 because 4 here 1 and 4 here 2, and I have my 2. Alright, the same thing applies to 8 over 2 because here's 1 and this is 4. Brilliant. So one more sample. This is going to be plus, I guess, 4 plus 2 equals 6. Now, who can tell me, quick one, how do I get my 4? This 4 or 2? So sharp, just tell me. Beautiful, got it. 6 minus 4 will give me 2, and 6 minus 2 give me 4. Hey, hooray! Did we all get it clear? Thank you so much for listening. Before I go, I don't have anything but just to ask you this question to see how well you have followed. Can you tell me how we solve problem involving arrow bars? It is simple. Come on, people. Yeah, we're going to think in quantitative reasoning along arithmetic line, and that involves operations like plus, minus, times, and divide. So thank you for listening. I remain Mr. Omota Godwin. Next time we'll meet again. Promise to be an interesting class. Bye-bye.